So here is another question from IIT JEE PYQ. The question is from the chapter friction here, and here is the question. A small block of mass 0.1 kg on a fixed inclined plane PQ, which makes an angle theta with the horizontal. A horizontal force of 1 Newton acts on the block through its center of mass as shown in the figure. The block remains stationary if. Okay, here are some conditions given. So let me draw the situation here. This is our inclined plane, and this is having a theta angle with the horizontal, and this is a block of mass m I am taking. I will substitute the value later. Okay, and a horizontal force of 1 Newton is acting on it. So let me suppose this is a force F that is equal to 1 Newton. Okay, so now let me draw the condition here. If this is the mg force acting in downward direction, and this is the direction of normal here, and let me take the component, this angle is theta, and the component of mg force along this normal will be mg cos theta. Okay, similarly this force is also making this angle theta with the horizontal, so I can take the component here, the component of this force along this normal. So the component of this force along this normal will be equal to what? F what is the component we will be taking here along this perpendicular direction? That will be F sin theta. Okay, similarly if I want to take the component in this direction, component of this force that is parallel to this inclined plane, that will be equal to F cos theta, and the component of this mg along this inclined plane, that will be equal to mg sin theta. Okay, so here I can write that if this block is in stationary, then n is equal to, normal force will be equal to here mg cos theta plus this F sin theta. Okay, and also the I will draw the situation here again now. This is our condition, this is our block. Okay, this is our block of mass m, and there is a force acting in the downward direction that is equal to mg sin theta. Okay, and there is a force acting in the upward direction that is equal to F cos theta. Okay, and due to this is our normal force, and the value of normal we have calculated here, that is equal to mg cos theta plus F sin theta. Okay, now we have to check out the conditions here. Our first condition, if this block is stationary, okay, the block remains stationary if, then for block to remain in stationary, that is there will not be any sliding of this block on this inclined plane. That means net force on this block will be 0. Okay, so mg sin theta will be balancing this upward component of force F cos theta. Okay, so here the value of this m is what? M is 0.1 kg, so it is 0.1 kg multiply the value of g is 10 multiply sin theta, that is equal to the value of F is 1 Newton multiply cos theta. Okay, so here this will be cancelled out, that is equal to 0.1 into 10. So tangent theta will be equal to 1, that means theta is equal to 45 degree. So here our option number A is correct. At theta is equal to 45 degree, this block will be in stationary position. Now if I increase this theta, let me suppose if I increase this theta, let theta is greater than 45 degree if I assume. Okay, then in that case what will be happening, this tangent theta will be greater than 1. Okay, so in that case if I assume this this equation I will write here again, that mg sin theta and this f cos theta. Okay, so if I write the value of this mg, that will be 0.1 multiply 10, so it will be 1 only. So this downward force acting on this block is equal to sin theta. Okay, and if I substitute the value of f here, then upward force acting on this block is what? Cos theta. Okay, so I will draw the situation here again. Now if this is our block of mass 1 kg, and the downward force acting on this block is equal to sin theta, and the upward force acting on this block is equal to cos theta. Okay, so now it is given in the question that if I increase this value of theta, that is greater than 45 degree, that means what? Let me suppose theta is equal to 60 degree, then the value of sin theta will be equal to root 3 by 2. Okay, and the value of cos theta is what? That means cos 60, that is equal to 1 by 2. So here I can clearly see that sin 60 is greater than cos 60. That means the downward force is greater than the upward force. That means block is having a tendency to move in downward direction. So in this case, friction will be acting on the block in upward direction. Okay, this will be the direction of friction force if theta is greater than 45 degrees. So frictional force. So here this upward point is Q and lower point is P. So this is our point P and this is the point Q. If theta is greater than 45 degree, then there will be frictional force acting in the direction towards Q. Okay, so this option B is incorrect here, because theta is greater than and a frictional force act on the block towards P, because it will not be acting towards P, it will be acting towards C. So C option is correct and our A option is correct. And at theta is equal to 45 degree and a friction force, so it is also incorrect, the D option, because at theta is equal to 45 degree our block is in stationary position, so there will not be any type of friction. Okay, at this theta is equal to 45 degree, the frictional force between them will be 0. Okay, so here two options are correct, one is A and another option is C.